The Alex assignment has to be 100%. So let me show you what I mean. Assignments. Okay, so the extra credit, the way that Alex is different than Delta Math, as you do problems, it's showing you your percent. Alex is not going to show you your percent until you've done it all. You submit it. So you actually do have to submit the assignment. So when you submit though, and up here, your problems will be green or red or maybe yellow if you got partial credit. Okay, so if you have some yellow or red problems up here that you got wrong, when you submit the assignment, this button right here, okay, it's going to give you a grade. And then, so I'll go ahead and submit this. Watch. I know I have a bunch undone. I got a 12 because I had only answered a few of them in my other classes. I've gone over some. But retake available means you can do a retake. You do not have to retake the whole assignment. So I'm going to do a quick retake, and you'll notice, see the ones that I got right? They're still right. I don't have to go back and redo those. They're already done correctly. So when you do a retake, your correct answers carry over. You only have to go redo the problems that either you had left blank or you got wrong. Does that make sense? And for the extra credit, bless you, there is not a limit to the number of retakes. There is a limit to the problems. Like if I'm answering number 1 and I get it wrong and it tells me try again, it'll only give me 3 attempts before it counts it wrong. Then I'll have to do a retake when I finish the rest of these. Does that make sense? Yep. So you have unlimited retakes until you get this to 100%. So you can, and it's not going to be the exact same problems. It'll prompt you with a new problem, a similar problem, the same concepts that we're trying to get you to practice, but it'll be slightly different. So if you were bothered by a question, you can't figure it out, just submit the assignment, do a retake, and it'll give you a new problem for that one. Okay? Yes. 5 points. Wait, just like last unit. Yeah. They're in the folder up there. And look, make sure you're looking in the honors one, not the level one. Okay, so let's start going over some questions. I know I had some people lined up, so I'm going to ask some specific people what their questions were. Your questions can be over this extra credit. They can be over the 2.6, Alex. They can be over the review. Anything that you have questions on from this unit, you can ask about. Okay, so Maxim, what's your question? Number 11. On what?
All right, can you do number 33, actually?
On the extra credit?
Yeah.
Okay, so I'm going to look at the extra credit, number 33. Not everybody's is going to be exactly the same. I'm not letting me go to 33. No. I already answered 33 in another class, but it should let me attempt more problems. That I did.
Yeah,
Oh, why it's not letting me? You should. It might be because I hit submit. That's annoying. Let me hold on. I'll open this in a different class period through Alex because I'm like doing mimic student view. But if I go to a different class period, it won't show submitted, so it should work. Let me pull it up.
Wait, this file, if it's a squiggly, does that mean that it's a no?
That means it's a negation. It's a not. It's an opposite.
Okay, that makes sense.
Yes.
Are the questions in the extra credit going to be like the
Some of them. So let me reiterate a couple of things. The review versus the Alex, like the format of the questions. So in the extra credit, when you're doing something like number 33, this is a proof, right? In Alex, it's having you start from nothing. There's no table. You just start. And every step you validate, and it'll tell you if that step is wrong. It's not going to tell you if you write something that's accurate, a statement and an accurate reason, it's going to let you put it. It will let you put extra stuff that's not really necessary. It's only going to stop you and tell you that's not right if it's incorrect. Like if your statement and reason don't match, or if you haven't, if you don't have enough above it to give that reason, if that makes sense.
Is our test on aware tomorrow?
Your test is an aware. Now on the review, your proofs look like this, where a table was given and you were filling it in. But I will tell you on the test, your proofs are going to be easier than both of these. I think the review is easier than the ALEKS. The test is going to be even easier than the review for the proof questions, because the table is there and it is mostly filled in. There are just some blank spaces on either the statement or the reason side, and you're just filling in what's blank. You're not having to do the entire proof. And when you go to fill it in, you're not having to type. You're drag and dropping from some choices. So the test questions for proofs will definitely be easier than the ALEKS and the review questions. So if you can do these, like, you're going to be perfect on the test. You will. It is definitely going to be easier because it's going to be drag and drop into the spots that are empty. Okay.
So you think it's like the test is going to be more like the review and not the ALEKS?
Yes, because the ALEKS is a little more nitpicky and lets you put extra stuff. Yeah. And like, it doesn't tell you how many steps this should be in. It's very open-ended. The test is not open-ended.
Okay.
There is a table of the proof there, and you're just filling in the few that are empty,
Okay.
and you have a bank that you're pulling from to fill those in.
Okay. And then is this like, are you going to keep that up tomorrow?
No.
Okay.
Yeah, y'all don't get any like reference sheet or like get to use your review or notes or anything like that. I'm going to erase what's on the board. So, I mean, you have to know your conditional statements and like the symbols, like the if P, then Q, all that stuff too. Okay, so I'm going to go back and do this proof now that I've answered that question about how the test is not going to be in this format where you're just starting from scratch and have to fill in everything. But if you can do this, you'll be good to go on the test. Okay, so I don't know that I mentioned this, but notice how if you started this extra credit assignment, it was like 37 questions and now it's only 33. I deleted some when I was helping some people yesterday and realized how lengthy some of the proofs at the end were, or how nitpicky it was being. So some of them were duplicated. I was having you do 2 of this type and 2 of this type and 2 of that type. So I deleted those extra. So you're just doing like 1 of each type in the extra credit. So that's why it got a little shorter, if you were wondering. Okay, so given the information, prove that the measure of angle PQR is equal to the measure of TSR. Our given information is here. Now I'm always going to start with my given. So you can you can go down here and you can type in these statements and select given, but you can also use this button that says send to proof and it'll automatically put that in there. So it automatically sent that information down and wrote given. So I sent my given information down into the proof. Okay, now I am going to look at my picture and see what it says. So it says angle 1 and 4 are equal. And it says 2 and 3 are equal. It wants us to prove that PQR, so that's here to here to here. So what makes up PQR? Angle 1 and 2, right? So I'm going to go ahead. I have to use angle 1 and 2 knowledge to answer this question. So I'm going to need to say that PQR is made up of angle 1 and 2. Okay, so I'm going to write them, and you do have to put measure. If you just put angle 1 plus angle 2, it's going to not let you. You have to put the measure of angle 1 plus the measure of angle 2 equals the measure of angle PQR. What is the reason for that? What is that rule that allows us to do that?
Angle addition.
Angle addition, perfect. So I would select angle.
What if it's like backwards? It gives me RVT is equal to SVU, and I have to prove that measure one is.
So you can still break it down of what angles it's made up of, and then there's an overlapping angle, right? So let me finish this one, and then we can see if I can find one like that. Okay, so the whole point of number 33 is you should be using angle addition property. Okay, so I know that PQR is made up of 1 and 2, and if you hit validate, it'll let you if it's correct, or it'll tell you if you've typed it in wrong. Okay, so then angle TSR, the one that I'm trying to prove that's congruent to, is made up of what? It's made up of 3 and 4. So then I'm going to write that angle sum. So the measure of angle 3 plus the measure of angle 4 equals the measure of angle, sorry, I forgot the name of it, TSR. Oh, did I type it wrong? 3 and 4 TSR. Oh, I didn't put a reason. Yeah. Okay, so my reason is angle addition. All right, so now I've said that those two angles that I'm trying to prove congruent are made up of these smaller angles. And I was told that these pairs of smaller angles are equal. So now I'm going to be able to substitute so that I can have these addition statements that are equivalent. So I'm going to take here angle 1 and 2. 1 is congruent to 4 and 2 is congruent to 3. So I'm going to take that statement. I'm going to copy and paste. Okay, and I'm going to substitute. Instead of angle 1, I'm going to put angle 4 because 1 and 4 are congruent, so I can make substitutions. And angle 2 is the same as 3, so I'm going to substitute 2 for 3. Okay, and my reason is substitution property. Okay, so I'm going to see if it'll validate. If it won't, it's because I did 2 in 1 step. It might make me break that down into 2 separate steps. Let's see. No, it didn't. It let me substitute both in the same lines. Okay, so I substituted those based on the congruence. Now you can see, aren't lines 4 and 5, these two statements, they're both 3 plus 4, aren't they? So if TSR and PQR are both equal to 3 plus 4, don't they have to be equal to each other? What is that rule? What is that property? If something is congruent to two different things, it must, those two things have to be congruent to each other? No, it's not a definition, it's a property. I think, let's think about it not mathematically. Let's say, I think I used this example yesterday. I said if I find out Julia and I have the same birthday, and then I find out Sophia and I have the same birthday, then doesn't it make sense that Julia and Sophia have to have the same birthday? What property was that? I'm not substituting. If A is equal to B and B is equal to C, A must also be equal to C. That's it, transitive. Yeah. So it's using the transitive property because both of those angle measures are equal to the same thing, they have to be equal to each other. So, and that's what I'm trying to prove. So I'm just going to send to proof. And it put it down there for me. I didn't have to type it in. Oh, I have to put the reason again because of transitive. You can validate, proof is complete. You can check and it'll tell you if your proof is correct or not. Okay. So, and if you have this completed, I think it should always have this button, try another, but I don't know that when I was doing it as a retake, it wasn't letting me try another. I'm not sure why. I think maybe, I don't know. I thought it would let you try an unlimited number of them. So is yours more like this, Maxim? Where they tell you the big angles?
Yes.
Okay, so we can look, this is kind of just in reverse of that. So I'm gonna send the given information to the proof. Okay, now let's break this down and zoom out a little. So it says that CWE is congruent to FZH. And 3 is congruent to 4. So we want to prove 1 is congruent to 2. So I still need those angle addition property or angle addition postulate statements to show that 1 and 3 make up CWE. 2 and 4 make up FZH. So I'm going to write those first. So the measure of angle 1 plus the measure of angle 3. What do you need, Aaron? In a conditional statement, yes. A biconditional does not start with if. A biconditional has if and only if in the middle. But if you have a conditional, a converse, an inverse, a contrapositive, those are all going to be if then. All right, so 1 and 3 make up CWE. That is angle addition. And I'm going to do the same thing. I'm going to copy and paste that and then just change the numbers. So 2 and 4 make up FZ8. For the same reason, angle addition.
It never gave me like measure of angle 1 equals measure of angle 2.
Because mine is in 2 separate ones, yours is just 1. Okay, but so you can write, let me see yours because I can't see that far. You could write your angle addition is going to be RVT. So 1 and 2 is RVT. 2 and 3 is SVU.
I did that. I said angle measure of angle 1 plus measure of angle 2 equals RVT. Angle addition instead of drawing.
Wait, yeah, damage or like, does it matter really? Like, yes.
Type it in and let me see it telling you wrong. You might have accidentally had a typo or something. Okay, so back to this one. Sorry, guys.
Just need one truth.
All right, so I've shown that the big angles here are made up of these smaller numbered angles. Okay, now I can do substitution like I did before. So we know 3 and 4 are congruent. So like in this one, for instance, I could replace the 4 with a 3 using substitution. And I could show that 2 and 3, the measures of those would still add to that same angle. Okay, and then I could show who am I trying to prove congruent? 1 and 2. So now here in line 3, I've got 1 and 3. I'm going to make that. He told us CW. Okay. So what I'm going to do here is I've got the CWE and the FZH. Those two that we were told are congruent. I've got this one in terms of 1 and 3, and this one in terms of 2 and 3. So since those are equal to each other, we already said that up here in the given information, then these 1 plus 3 must be equal to 2 plus 3. So the measure of angle 1 plus the measure of angle 3 must be equal to the measure of angle 2 plus the measure of angle 3. And that's substitution again. Okay, I'm replacing things. So now since both sides have the measure of angle 3, I could drop the measure of angle 3 by subtraction because it's being added. So if I subtract it from both sides, it eliminates, it's gone. So that would leave me simply with the measure of angle 1 equals the measure of angle 2, which is what I'm trying to prove. So the reason I can drop that 3 on both sides is subtraction. And they have addition and subtraction together. So you would select that.
First the 5, why did we get
That one go. 5. I did a substitution. So we had said here that angle 1 and 3, or actually, I think I copied this one. We said angle 2 and 4 added to FCH. And we know that 3 and 4 are equal. So I replaced the 4 with a 3. I substituted it. And the goal, the reason I did that was so that I could get both of those angles that are congruent, both to have angle 3 in them, so that I could drop it and be left with the 1 and 2 only. Because you don't have measures. You gotta have the measure of angle RBT. No, it's just the, yeah, it is nitpicky about how you type it. So yeah, that was just a typo. Okay, what else? Who has a question on the review or anything else?
Can you walk us through 13 and 14?
On the review? Yes. Okay, so here is now there was a typo here that M at right here in front of angle XYA, that M should not have been there. Just mark it out. Okay. On number 13, there's an M for measure that should not have been there. Because when we have we either have a congruent statement saying these angles are congruent, or we have a measures are equal statement. Okay, so you shouldn't have the measure, the little M, with a congruent sign. Those don't go together. Okay, so that M should not have been there. But what we're told here is that ray YA bisects XYZ. Okay, so that's given. Always start with your given. Now, the definition of an angle bisector, they're telling me this is an angle bisector, and what an angle bisector tells me, or what it's defined as, is something that cuts an angle into two congruent angles, right? These pieces, these measures must now be equal. So the measure of angle XYA must be equal to the measure of angle AYZ by definition of angle bisector. Then we can go from the equality statement to the congruent statement using definition of congruent. Because if measures are equal, then angles are, then they're congruent. That's what congruent means. It means equal measure. Does that make sense? Okay, and then which one? Okay, so 14, I'm going to say something extra about after I walk you through it, because this is not the only way. And it's actually not the way that I would have done it. I would have done it in more steps, actually, because they give you the table and there's only 3 spots. They're saying do this in 3 statements, which I'm not sure how much I agree with. So I'll explain the way I would have done it otherwise. You got it? Awesome. Thank you. All right. So I start with my given statement, which is that angle 1 and 2 form a straight angle. Okay, that's given. Now, the definition of a straight angle is that it's 180 degrees, right? A straight angle is 180 degrees. So the name of that straight angle is ABC. Do y'all agree? Yep. So angle ABC is 180 degrees. And I should probably say the measure of angle ABC. If this was in Alex, you would probably have to put that little M. It would be nitpicky about that. Okay. Then I know from this picture, I can see these are adjacent angles, right? These 2 angles added together equal that straight angle, don't they? So the measure of angle 1 plus the measure of angle 2 must equal 180. That's the angle addition postulate. So that's what they were the key to the review says. And I didn't write this review because I would have given you more lines to put steps, because I would think you should be more specific than this, adding more things in. So what I would have actually, if this was not told to me to do 3 steps, I would have started with probably saying angle 1 plus angle 2 equals angle ABC. So I would add that step in between these 2 to say that angle 1 and angle 2 form angle ABC. And that would be angle addition postulate, or and then say that ABC is 180 because of the definition of straight angle. That's fine. Okay, and then I would say, okay, so the measure of angle 1 and the measure of angle 2 equals 180. And I would have done that by substitution, because up here I would have already put that 1 plus 2 equals ABC. Do y'all understand what I'm saying? I think that step really should be added in there between 2 and 3. All right, what else? Allison, say again?
16.
On the review? Okay. So if you scroll down, I'm going to scroll down here. 15 and 16 are asking for counter examples. You have to know that a counter example is proving the statement wrong. When we say prove it wrong, a statement could be true some of the time. That means it's false. If it is not true 100% of the time, it is false, and you give a counter example. So the sum of two numbers is always greater than two numbers. That can be true. If I add 5 and 6, I get 11. 11 is greater than 5, and 11 is greater than 6. But it's not always true. So it is a false statement, and they ask for two counter examples that it's going to be negative numbers. So if you add two negative numbers, you get a less, okay, further left on the number line, negative number, right? It's more negative. So it is not greater than, okay? Or if you add a positive and a negative, okay, this answer is greater than one of those. Negative 5 is greater than negative 6, but it's not greater than both of those numbers. Okay, so your examples could be different, but that was that. Now in 16, draw a counter example. We just want a drawing that proves this statement is not always true. So it says if M and N lie on line LO, that M must lie on segment OL. I'm trying to prove that wrong. I don't want M to be on segment OL, so I need to draw M outside of O and L. O and L can be anywhere on the line for the line to be called LO, right? But for the segment, it only goes from O to L. So this is segment OL. I'll highlight that, bless you. So segment, why are you not highlighting? Okay, well, my pen stopped working. It's not, I was going to highlight segment OL and then highlight this portion. That is segment OL. As long as you didn't put M in between O and L, you have a counter example that works, that proves it wrong. Because M is still on this line, but it's not on this segment. Y'all agree? Okay, what else?
Can you do 9?
On the review?
Yeah.
Well, maybe this whole thing froze because now it won't let me change pages either. Let me see if it let me close out and reopen it. Okay, here we go. All right.
This review will be posted too.
Yep, I'll post this after school today. All right, so on number 9, we have an algebraic proof. Remember, we did some of these in our practice worksheet on algebraic proofs. If one of your sides of your equation is a fraction, you've got a denominator, the whole side is being divided by something. To get rid of that divided by 2, the opposite is to multiply. So the very first thing we do here is we multiply by 2. So it's the multiplication property that gets me from the given statement to my statement 2. Which when I multiply by 2, if you need to show that, let me see if my pen will work now. If you need to show multiplying by 2, that cancels, not really cancels the wrong word, that reduces, okay, 2 over 2 is just a 1, right? And 1 times something doesn't change it, so it goes away. We don't have to write it. So it's just the numerator, the x plus 3 that's left. And then over here, 12 times 2 is 24. Then to get rid of the 3, we subtract it over. So that's the subtraction property that leaves me with x is 21. 10 is on the screen if you want to go ahead and check that you did that correctly, or do it if you didn't do it. We have to know the difference in postulates and theorems. That is a question on the test. Promise you. A postulate does not require proof. A theorem does. And you've got to know that order of the Euclidean geometry. Undefined terms. It goes basic to more advanced. So the undefined terms, that's what everything's built on. Point, line, plane are your undefined terms. Okay, then your defined terms, then your postulates that don't have to be proven, but are accepted as true, then your theorems. Theorems can be proven. Okay, you can use everything underneath it. In a theorem, you could use a postulate, you could use a definition, right? The theorems are at the end. Theorems use everything that come before them. What else? Allison, were you about to ask another one? Okay, yes, it is. Glad you asked. Number one, I think y'all should be able to do pretty easy, or I hope pretty easy, because it gives you an if-then statement. Pretty straightforward. Make sure you know inverse, converse, contrapositive, and biconditional. 2 is tricky. So I put some notes in here. It's highlighted in yellow. It says an angle is an obtuse angle if its measure is not 25 degrees. So that is not in if-then form, is it?
No.
So that's what I put here. If P, then Q. That's our form that we want it in. Okay, what comes after the if is the hypothesis. Okay, and then what comes after the then is the Q. The Q is conditional based on P. That's why it's called a conditional, because part of this is based on whether or not the hypothesis is true or not. So if you want to rewrite it in the proper if-then form to make it make more sense to you, I would do that. And that's what I did right underneath here. I put it in conditional form. I said, if an angle measure is not 25, and I changed the wording a little so I didn't start with it. Okay, instead of saying if its measure, I said if an angle's measure is not 25, but that's the part that came after the if, right? So that's my hypothesis, my P. Then, and then my conclusion is it's an obtuse angle. That's my Q. Once you rewrite this or rephrase this into if-then form, then I think it's easier. Now, what's also confusing on this one, or a little tricky, is that there's a not in the original statement. Do y'all see that? If an angle's measure is not 25. So when I go to do my inverse, if I were to say if an angle's measure is not 25, I have like a double negative, right? That just negates it. That's the point of an inverse. You negate the statement. So a double negative becomes a positive. So instead of saying not 25, we just drop the not. The opposite of not is to not have a not. Do y'all understand what I'm getting at? So the inverse actually says if an angle's measure is 25, because that's the opposite. That's the negation. Then it is not obtuse. You have to negate both the P and the Q. So that one is a little tricky. You have to pay attention to that for your inverse and for your contrapositive, because those both use negations. What else? Nothing from the extra credit or the 2.6, Alex? I will tell you, if I didn't already say this, the truth tables are not, there's not a truth table question on the test. So if you're struggling with those truth tables, just know they're not on the test.
The truth table is the like.
In the Alex, where you say the true, like you make the columns with the T's and the F's.
Oh. Okay.
There's not a question like that on the
Can
test.
you go
No,
back
what is-
on the number 13 on the review?
13 of the review? Yeah.
Kind of.
What were you asking about?
Like, what do you think is gonna be mostly, like, what should we study the most? Like, what's gonna be?
What's on the paper review?
Most, okay, like, okay.
Yeah, if it's on the paper review, you need to know it. Like, not the exact questions, but those
Yeah.
types of questions. Now, some of them are exact, like you have to know the order of Euclidean geometry. There's no other way to word that question. That question's on the test, right?
So there's no writing too, right?
Yeah, but in the proofs, you are gonna have some algebraic proofs, some geometric proofs,
Okay.
but they're all gonna be like where just some of the slots are empty and you're drag and dropping what should go there.
Okay.
So there's gonna be choice of
Alright.
like what you should be using.
The order of the thing is undefined, defined, postulate, theorem, right?
Yes.
Okay.
Yes.
You go over 13 though.
Mhm.
I just wanted to make sure.
So in 13, remember I told y'all to mark out that M. Okay, that was a type, that M was not supposed to be there.
Wait, mark out what?
The little M right here where I have this black blob.
Oh.
Okay, that little M for measure was not supposed to be there. So given that YA bisects angle XYZ, so that tells me it's an angle bisector. It bisects an angle, so it's an angle bisector. So I write out my given information and then I use the definition of angle bisector to say, okay, if this is bisecting the angle, that means the measure of these two smaller angles are equal to each other. That's the definition of an angle bisect. Bisect means cut in half. So those measures are going to be equal to each other. And then if you know measures are equal, then that means congruent. That's the definition of congruent. Equal measures means congruent. You can go from a measures, equal measures statement to a congruent statement and vice versa using law of congruent or definition of congruence. Can you put it 8, please? On the review.
Yes.
So this was an algebraic proof, number 8. I think most of you can do the algebra, but that part was already done. The statements were all here. You have to give the reason for each step. So you have to understand what's happening. So first, it's distribution. Then you're adding the x over. So that's addition property. Then you're subtracting the constant. So that's the subtraction property. Then you're dividing out the coefficient. So that's the division property. I trust y'all can do the algebra. It's just understanding what property is being used in each step that you need to make sure you know.
We have to memorize all the problems.
So you have to, you know, like you're not having to draw them out of thin air. You don't have to have them memorized in that sense. But like if you see it written, you need to know what it is. Like
Okay.
what that, like if you see addition property, like you have to know what that is. But you don't have to remember like have all the names memorized because there will be like choice in what you're dragging down into the empty spot.
Wait, okay, so for 8, like, you see how it's like say the third one, it's subtracting, but it's like addition property, for these to be like one step ahead.
No. Yeah, see, that's why I draw the arrows. What the rule or the reason that you're writing is where this statement came from. We got this statement because of what we did up here.
Okay.
Okay, we got this statement 3 because we added 3x. We got statement 4 because we subtracted 10. Does that make sense?
Yes.
Can I check with 14?
So you must have been doing something else because I went over these already.
Oh, well, yeah, I was thinking
Watch the video later if you need to hear the explanation.
Sorry, I was thinking.
All right. And post these videos and the key right after school. So if you have additional questions we didn't get to, you can go, and I'm going to post the video from 4th period also. So they may have asked some questions or may have gone over stuff on the extra credit or something that we didn't in here. So use those resources and come prepped with a completed review. The review is a grade, a double daily grade.